Hello YouTube. So earlier this week I put out an animation. I'll probably be showing it on screen, and it involved me having a truck sitting in the middle of kind of a beach environment. And well, one thing that I found very interesting, and a lot of individuals who saw the render found very interesting, was the water at the beach. And I was looking through it, and I found the water I used was I had actually made a very interesting material setup for it. And I figured, why not show how to make it? So really what I'll be showing is how to create water with some really interesting looking caustics. Caustics are not a strong point of the Cycles render engine, and I found this shader to be relatively performant. And honestly, once you get the node set up, especially with Blender's upcoming asset browser functionality, it's really not as bad to implement as you would think. So why don't we kind of jump into it then? What you're going to see is right now I have a blank Blender project set up, or not blank, but basically two planes. This one will represent our water, this one will represent our basically underwater area. I just used a texture from Megascans for this. So first things first, well, we should be in the Cycles render engine. I set to GPU compute. And of course, we want to be using the experimental toolset for some adaptive subdivision, which we'll kind of go over later. So let's create a new material and call this water. So first things first, we actually just want to get rid of our principal BSDF. And we also want to do another thing. We want to give this water some volume. So I'm just going to use a solidify. You could also just import a cube. And now that our water has some volume, well, first things first, why don't we just give this a nice volume absorption shader. So this volume absorption will really just kind of serve to, well, take a little bit of the edge off when or give this water a little bit of an appearance of volume, as its name implies. And I generally set this to a nice blue. You could really set this to whatever color you want. I wasn't really concerned with a physically accurate color. I wanted the render to pop a little. So from there, well, let's think about the best material that we could use. Well, a good material to start off with for a water material is, well, of course, the glass BSDF. Once again, this only works in Cycles. So our glass BSDF is now in, and I'll actually turn on optics denoising just to make that render look a little better. And we actually want to set this to 1.333. You could keep repeating that. Just to set it to the index of refraction of water, or basically a measurement of how refractive the material you're dealing with is. And having a physically accurate color is important for the shader to look right. I'll also set this one to a little blue. Once again, not strictly necessary. I just like the color to look a little poppier. So from here, well, first order of business is, I would say, to get our water bumpy. So we can just plug in a simple noise texture into a displacement and out into the height output. I like to change this to world space. It makes it look a little better. And we can plug that into our displacement. So one thing we'll notice with displacement right now is, well, number one, we're actually getting, it's not looking the geometry is not actually there. It's just basically being faked by the renderer. So what we can do is, well, there are two things. First things first, we actually have to go into our material settings, and I like to set this to displacement only. And not much is going to change. This is because we also need to give it some geometry to work with. So in this case, I'm using a subdivision surface set to adaptive subdivision. And now all of a sudden, we have bumps. I'd like to take down the scale to this, just to kind of make it a little more realistic. So once again, you're going to kind of notice that, well, we have a pretty good basic glass shader, but the water, I think, needs a little more bumpiness. So what I'm going to do is I'm also going to make it so I don't have to subdivide too much. I'm also going to plug in a little bump shader, or a little bump map, into our normals, and I'm going to plug the height directly into here. I can then scale this down a bit, and we end up with, I'm not sure if it's particularly noticeable, but we'll basically end up with little bumps. I can actually scale the texture up a little bit and add a little more detail to make that a little more apparent. You kind of see it now. So from here, we kind of have a really decent well, water shader. It looks like water, but there's none of that nice caustics interaction going on under the surface, which is fine if you're doing a deep water situation. But when you're starting to have to deal with a shallow body of water, having those caustics might make it look that much better. So a good place to start for caustics is a nice and simple Voronoi texture. We can actually use 2 of them to break it up a little. So I set mine to 3 and 8 for my scaling. You can do whatever looks best to you. And I also set these to the distance to edge method. It gives a sharper appearance versus the standard F1. So distance to edge gives these nice, clear lines. From there, what we can do is we can pull a nice greater than, so we can pull a math operation, and we can basically see if this is greater than, in this case, 0.01. What you're going to notice is it sharpens up this material a lot. And we can copy that over to the next one too. So now we have kind of 2 textures. We have 2 caustic textures that have 2 varying levels of noise. Well, what we need to do is we need to combine them. Fortunately, we can just pull a mix RGB node in here, or you could also just pull a simple multiply node, but we'll just set this to the multiply operation. And you're going to notice these mix now. So next up, well, we probably want to give this a little noise into how it's basically being applied. So I'll just mix in a noise texture. And I'll scale this down a little bit, and I'll up the detail a little bit, set it like 5 or so. So from here, what I can do is I can then pull another multiply node and just multiply it with this shader. You're not going to notice much of a difference, but it's subtle and it gives a little bit of variation. We'll actually be breaking this entire pattern up a little bit. Finally, we can actually plug this into an arctangent 2 value. So you might ask why the arctangent 2 value. It's because it will ramp every value super hard on the side. So if we actually go into math and we just plug this into an arctan 2, we can get a little more. It won't show particularly well. Let me set this to 0.59. It won't show particularly well, but it's causing a slight shift in the values to kind of really quickly ramp them on either side. It's how the arctangent function works. If you actually take a look at a graph of it, you'll see what I mean. So next up, well, we have a really nice caustics pattern that we can kind of work with now. And there's something, so we can kind of start getting our caustics implemented. So we have our transparent BSDF that we can map to a value. Let's say 2 in this case. And what this does is this actually makes it almost emissive in a way. It makes it still transparent, but it kind of gives it a brightness value while still retaining its transparency. From there, we can just mix this with another transparent BSDF. I have Node Wrangler enabled, that's why I'm able to do this. And we're actually just going to use this as the factor. So you're actually already seeing this kind of caustics pattern being implemented now on our surface. But the one thing else we want to do is we actually just want to do another value plugged into here. We'll actually just duplicate this entire node setup. And we're going to set this to -1, which if you don't know, will look like this. It'll look black, but when we use an add shader, it will basically subtract some of that emission away, which gets a little important later. So now we can start doing some fun stuff where we mix this add shader with our glass shader that we implemented earlier. Once again, that plugged into displacement. I do not know why. So if we plug these in, we're going to notice we get a weird kind of patterning here, and it's because we've plugged our displacement in. So now we kind of have our glass mixing with our our fake caustics shader. And overall, it looks decent. We'll be messing with the scaling values of these Voronoi to make it look a little better later. So from here, we can just define where the caustics are going by changing this mix shader. Right now it's just a 0 or 1 value to a light path, which just basically says, okay, is this a shadow ray? In which case it swaps it to our next shader. And this is where you're kind of able to see, well, now it's moving to an actual caustics pattern that's projected on the bottom. And it actually looks fairly good already. You can already see the bump texture, if we actually mute this, is having a bit of an effect, and the displacement texture too. Not sure how apparent that is in video, but it's noticeable. So we've kind of really set this up, but I think we need to apply a little bit of, well, transformation to our caustics pattern, because right now it still looks very Voronoi-ish. So what we can do is we can actually add a mapping node and map every one of these, and we'll actually, oops, I think it's this, yeah. And we can map every one of those to its own kind of separate one. We're plugging this into we're plugging these into the same shader. You'll see why it actually, because we're going to be doing some transformations on our caustics pattern, just by exploiting the mapping node. So what we can do to do that is we just plug this in. I use the linear light blending mode. And it's not going to look like much at first, but that's because we haven't mixed it with anything. We actually want to mix this with a noise texture and a map range. Oops, I did not mean to duplicate that. The map range basically just allows us to specify a smaller ceiling value. You could do the same thing with a color ramp. I just like how the map range just makes it look a little cleaner. We'll just set some values. These are largely arbitrary. You can tweak them to however you would like. And we can plug this in. And already you're kind of noticing, we can actually scale this value down, adjust our caustics, but what it's basically doing, so, this starts looking good, is it's using this mix RGB to mix this vector input and this map range input into a separate vector, which you see adds some noise to the transformation. So it's basically telling the shader that this point is actually over here, which gives us this really kind of breaks up this Voronoi effect and makes it, in my opinion, look a fair bit better. So, believe it or not, we're actually a large bit of the way there. I also set this to object shading. We're actually a large bit of the way there on our shader. And in fact, if you're just doing a still render, there's not really much else you need to do here. This is, you could, tweak some settings, call this a render, hit render on this and call it a day. But I think we can do a little more on this. And that's where we can really start dealing with, well, our the same concept of shader transformations, where we're basically affecting our axes. In this case, let's say we want the water to flow like we did in the animation. So what we can do this by simply adding another texture. So right now we have this set to a certain value, right? Set from our object coordinates. But we can actually split this vector out by separating the X, Y, and Z components of it. And we can, of course, combine them again. But this gives us individual control over the X, Y, and Z transformations. So we can choose to individually affect the X, Y, and Z depending on how we want to. In this case, I affected the X in the animation. So right now it's not going to look good. That's just simply because right now it's saying there's no X data, so it's going to look quite odd. So first things first, what we can do is we can just chuck in a nice little add, math. It's a map node, but set to the add operation. And as we kind of see, it's going to be the same shader for now, but if we adjust this value, it will shift the water. It basically shifts it over. And so what we can do is, if you haven't guessed, we can map these to some, well, relatively different values. In this case, I used a Musgrave texture. So if I use a Musgrave texture, I used two actually, we can actually set these to scaling values that look good. So for example, I'll actually just plug this one in right now. You can actually see how we're affecting our little shader here. So in this case, I set this to, and the actual animation, I set this to 40. That's probably too big though in this setting. And I also set this to a multiply. I could also pull a map range in there. Actually, I'll do a map range here. So what we can do is we can actually set this to have less of a value. So in this case, let's say I wanted to set this to 0.2. It's now at 0.2% of the intensity. And just to show you that it works, we can also do a math, multiply, and 0.3. And from there, we can actually multiply that by a smaller value. You're actually seeing the effects of that. So in this case, I still think that scaling value is a little big. So I'm going to take this back, a fair bit of the way, maybe 2. It's all dependent on how you want. One way you can actually look at it is this way, and you can actually see how much it's transforming each vector by. So I'm actually going to do this again. I'm going to duplicate, actually I only want to duplicate this one, and I'm going to map this one to a smaller size, so maybe 1. In this case, what we can then do is we can have the same multiply node, and then we can do another math node that will sample the maximum value. So basically, it'll take the greater of the 2 values, right, to basically perform that transformation. I think I should actually scale this up a bit, just to give this is kind of your ripple pattern in the water. This also allows you to see how this kind of works. So from here, what we can do is, we'll plug it into our value, and we'll preview our shader real quick. You see that looks fairly decent. But right now it's still not animated. All we've done is distort the water. And this is where we can finally plug this into a mapping node. And this is where the last step is all we do is just give this a driver. So, hashtag frame. The hashtag in front is just to show that this is a driver, and frame just is the variable that defines the frame of the animation. And then we can just do, in this case, I think on my animation I did over 10,000. Now this is a really difficult value to dial in, and the reason is that, it's difficult to preview in real time, as you're kind of seeing this render kernel or this render, this rendering. It takes a while to update. So a real-time animation really isn't that amazing, and it doesn't work with Eevee, so that kind of becomes out of the question. So really my advice for this is to tweak your values until you get something you're happy with. That's really all I can say about that, is you have to kind of, it's a lot of value tweaking until you reach a result that you like. So once again, we can do a whole lot with this. We could also plug in another math node here, set this to have less of an effect. So in this case, maybe 0.2. And now this is if we actually mute this add node, you can actually see it as a little bit of an effect. Right? See, it just lessens the effect of this Caustics. So, but all in all, this is our water shader finished. This is really all you need. So it's a pretty big node setup, but each part can kind of be broken out into its own chunk. So for example, this is the caustic, this lower bit is the Caustics section. This is the most complex section. This is the surface setting, and this just controls the mixing of the Caustics. All this stuff over here is just some mapping stuff to make it so we can animate the water. Which once again, if you're dealing with this for a still animation, really isn't a huge deal. So that's really all I have. There's so much you can do with shaders in Blender, and this is just a tiny example of this. My advice is, just go and make this shader and then start iterating on it. Start trying to improve it, and feel free to use it in your renders. So aside from that, that's about all I have for today. So as always, have a nice day.